Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 12 Linear Programming in Exercise 12.1 First Sum. So here the question is solve the following linear programming problems graphically and maximize z equal to 3x plus 4y and subject to the constraints is given. Okay, totally we have three inequalities here. Okay, so what actually we need to do is using the given inequalities, that is constraints, we have to identify the common solution for all the three inequalities. And then we are going to see how the common solution is. Common solution, whether it is feasible or not first. Okay, if it is feasible, whether it's a bounded or unbounded. Okay, then even if it is bounded or unbounded, what we are going to do is we are going to take the corner points of it. Then at which corner point the z value we are getting the maximum, and also maximum value we are going to find out of it. Okay, so step by step let's solve it. So here using the constraints we have to find out the common solution, right? So for our convenient, what I'm going to do is the given inequalities I'm going to take it as a equations. So let x plus y equal to 4. Okay, now this linear equation gives you the straight line in a graph, right? So to draw the straight line, we need minimum 2 points. So I'm going to take the 2 points. If x equal to 0, what is the y value that we get? If x is 0, if you substitute in this 0 plus y equal to 4, then y equal to 4. If x is 0, y value is 4. If y is 0, what will be the x value? X will be 4. So we have 2 points now to draw this particular equation x plus y equal to 4. Okay, so first point is 0 comma 4 and second point is 4 comma 0. Okay, and the other inequalities, what are the other inequalities we have? X greater than or equal to 0, right? So as I told you, the constraints we are going to consider as a equation to draw it in a graph. Okay, so x greater than or equal to 0, x equal to 0. So what is the x equal to 0? So where we have x values as a 0 at y-axis, the complete y-axis will be the line of x equal to 0. And the other one, y greater than or equal to 0 we have, right? So what is that? Y equal to 0 is what? So y equal to 0 is the complete x-axis line. Okay, so now let's start drawing the graph now. So we know very well that all this linear programming, this particular application based sum, always we will have in the first quadrant. So it says that no, so x greater than or equal to 0, y greater than or equal to 0, it means that our solution always will be in the first quadrant. Okay, so give more space for the first quadrant. So if it is a proper graph, we can able to mark it uniformly, the values. So here it's a tentative. Okay, so x equal to 0 line, y equal to 0 line. So what is that? X equal to 0 line is this one. Okay, this is what? X equal to 0 line. And what is the actual given inequality? X is greater than or equal to 0. After drawing this particular line, x equal to 0 line, you can see the graph is dividing into two parts. One is the right side, other one is left side. Now, for the given inequality, what is the suitable solution space? X greater than or equal to 0 is given, right? So x greater than or equal to 0 we will have only in the right side. Okay, so we will have a solutions this side. You will have a solution this side. So just remember, x greater than or equal to 0 is the first quadrant and fourth quadrant is the solution for x greater than or equal to 0. Okay, and the next one, y greater than or equal to 0. That means y equal to 0 first we have to identify. Y equal to 0 is what? It is y equal to 0 is x-axis. Okay, so x-axis is the y equal to 0, this particular line. Okay, now after drawing this y equal to 0, this red line, you can see the graph is dividing into two portions. One is above the x-axis, the other one is below the x-axis. And what is the given inequality? For the given inequality, the suitable solution space we have to identify. So what is the given inequality? The given inequality is y greater than or equal to 0. So y greater than or equal to 0 means it is above the x-axis. So that means first quadrant and second quadrant is the solution space for the y greater than or equal to 0. So you understand, for the first inequality, first quadrant, third quadrant is the solution space. And for this particular y greater than or equal to 0, for this, first quadrant and second quadrant is the solution space. Now what is the common solution for these two? Obviously, the first quadrant. So remember, out of 4 quadrants, step by step we are eliminating. Now we will have only the solution space in the first quadrant. Now using this particular constraint, we need to identify the common solution. So just like filtering. Okay. Now to express y equal this particular inequality, I have rewritten as a equation to identify the line in the graph. So what is the point that we have 0 comma 4? So where do we have 0 comma 4? 0 comma 4 is here. Sorry, here. This particular point is 0 comma 4. 4 comma 0. This point is 4 comma 0. Only in the y-axis. Sorry, in y-axis x will be 0. In x-axis y will be 0. Okay. Now, on joining these 2 points, what we will get? On joining these two, we'll get a straight line. So this particular straight line is what? X plus y equal to 4 line. Okay. After drawing this line, x plus y equal to 4 line, you can see the graph is dividing into two portions, right? So one is above this yellow. Okay, yellow line. So this particular portion, and the other one is this particular portion. So for the given inequality, where is the solution lies, that we need to identify. Okay, for that what we can do is above this line. Okay, above this line, take any point in this plane. So what points we can take? We can take 5 comma 0, we can take 5 comma 1, 5 comma 3, anything you can take and just substitute in place of x and y. Okay, so let me take randomly 5 comma 3 shall we take? 5 comma 3 point which lies this side, right? 5 comma 3. I'm going to check whether this inequality satisfies or not. So if I replace, in place of x as a 5, in place of y as a 3, the answer is 8. Is that 8 is less than or equal to 4? Which is wrong, right? That means our solution is not lies in this side. So solution is not lies in this side. Then obviously the other side also take any point and substitute and check. Okay, substitute and check roughly. Substitute and check. So always if 0 comma 0 will be easy to substitute, no, for simplifying also. So I'm going to replace x as a 0, y as a 0. Then result will be 0. Is it 0 is less than or equal to 4? Is it condition satisfies? Yes. 0 is less than 4. Condition satisfied. So what we can say, no, our solution lies this side. Okay. For the given inequality, solution lies this side. So it is like x plus y less than or equal to 4, right? So equal to 4 along with the straight line, and this side we have a solution. And for the x greater than or equal to 0, where do we have a solution for that? We have a solution this side. We had a solution first quadrant and the fourth quadrant. Y greater than or equal to 0, where do we have? Where do we have the solution for the y greater than or equal to 0? First quadrant and the second quadrant, right? Now, for the all three inequalities, do you see a common solution? Yes, we can see, for all the three inequalities, we can see the common solution in this particular portion. This particular portion. Okay. So this particular portion is a closed figure. We are getting, it's made up of only the straight line. It's a closed figure. So if you notice that a common solution exists, then we can say it is feasible. Okay. If common solution exists for the given constraints, then what we will say, it is feasible, and then it's a closed figure, right? Then we can say it is bounded. Okay. So the given Z is, it's what? It's basically feasible. Feasible means solution exists. And you can see the common solution, it is in the closed figure we are getting. So it is bounded. Okay. So for the bounded, what we need to do is we have to take the corner points now. So what is the corner points? We have drawn the straight line, no, x equal to 0 line, y equal to 0 line, and x plus y equal to 4. So these two lines meeting point, we call it as a corner points. Okay. For the bounded space, wherever you see the two lines meets, no, that we will say it is a corner point. Okay. So here, so basically this is the bounded space, right? This is the bounded space. Okay. You can notice that x equal to 0, y equal to 0 meets here. So this will be one of the corner point, and this will be the other corner point 4 comma 0, and this will be the other corner point 0 comma 4. So totally how many corner points we got? 3 corner points we have now. Okay. So we'll write the same. If you want, we can also name the corner points. So O, A, B, we can name it. Now what we can say, given Z has feasible solution. Feasible solution means what? Common solution exists, and it is bounded as well. Okay. And corner points are, what are the corner points? 0 comma 0, 4 comma 0, and 0 comma 4. Now we need to find out the maximum value. So in a given question, what they said? Maximize. What they said? Maximize. So maximize means maximum value of the Z we have to find out. So you can remember. So here corner points. And here what is the given Z? The given Z is 3x plus 4y. 3x plus 4y. Okay, now how many corner points we have? 3 corner points, no? One by one, let's substitute 0 comma 0, 4 comma 0, and 0 comma 4. If we substitute in place of x as a 0, in place of y as a 0, the result is 0. Okay. Next, if you replace x as a 4 in this z, 3 times of 4 plus 4 times of 0, which gives you 12 plus 0, the result is 12. Okay, next 0 comma 4, if you replace 3 times of 0 plus 4 times of 4, which is 16 we are getting. Okay, so what is the question is demanding? Maximize the Z. Okay, maximize means what? Maximum value. After substituting the corner points in the Z, you can notice the 3 different answers. Now, out of these 3, which is the greatest value? 16. Then 16 is the maximum. So, the maximum value of the Z is maximum value of Z is 16 at what point? 0, 4. Okay. So that's all the solution. What actually we need to do? Quickly I will tell you what we have to do is the given constraints. Okay. The given constraints. Using that, what you have to do is you have to identify the solution space in the graph. Okay. Sometimes we will have a common solution. Sometimes we may not have a common solution. If we have a common solution, then we can say it has a feasible solution. If it is not feasible, no solution for that. Okay. So we can notice that for the 3 given inequality, common space exists. Okay, that means feasible solution we have, and for also the feasible solution, it is bounded. You can see a closed figure. Okay, it is bounded. Since it's a bounded, we can also identify the corner points very easily. Okay, so identify the corner points and substitute one by one the corner points in the given Z. Identify the maximum value. That's all the solution. Okay. Thank you for watching. The next sum I'll continue in the next video. Thank you, and please do subscribe. Thank you.